Verse of the day. The Lord is not slow in keeping his promise, as some understand slowness. He is patient with you, not wanting anyone to perish, but everyone to come to repentance. So we're going to start with immunology today. Immune system organs. There are primary organs and there are secondary organs. The primary organs are the bone marrow and the thymus. Secondary organs are the spleen, lymph nodes, tonsils, and Peyer's patches. So, primary organs: bone marrow, immune cell maturation, B cell maturation, thymus, T cell maturation. Okay, so what they're saying is B cells and T cells are made in the bone marrow because B cells and T cells are the immune cells. So B cells and T cells are made in the bone marrow, and then the B cells mature in the bone marrow. In the thymus, T cells mature. So T cells mature in the thymus. The secondary organs are spleen, lymph nodes, tonsils, Peyer's patches. The secondary organs allow immune cells to interact with antigen. T cells and B cells are stored in the spleen, lymph nodes, tonsils, and Peyer's patches. Yeah. So after the B cells mature in the bone marrow, the B cells are stored in the spleen, lymph nodes, tonsils, and Peyer's patches. And after the T cells mature in the thymus, the T cells are stored in the spleen, lymph nodes, tonsils, and Peyer's patches. Okay. Next. Lymph node. Secondary lymphoid organ that has many afferents, one or more efferents, encapsulated with trabeculae. Functions are non-specific: filtration by macrophages, circulation of B and T cells, and immune response activation. Okay. What they're saying is a lymph node is a secondary lymphoid organ. Right here, right? As it's a secondary lymphoid organ that has many afferents. Afferents are things coming into the lymph node. I'll just show you when I find it. There it is, down here. So they have many afferents coming into the lymph node. Afferents are things like a vessel coming into the lymph node. Okay, and then a lymph node has one or more efferents. What are efferents? The efferents would be this things exiting, a vessel exiting the lymph node. This entire thing is a lymph node, and we have an afferent lymphatic right here, and a efferent lymphatic exiting the lymph node here. Okay, so lymph node has many afferents and one or more efferents. And lymph node is encapsulated with trabeculae in B. Okay. This right here would be the trabeculae. See this. Oh. So the lymph node is encapsulated. So this is the capsule, right? The outer. And then the trabeculae is right here. See this? This is the trabeculae. Um, I'll show you a better picture. So right here, this is lymph node, and this is the capsule, the outer layer, and the trabeculae is right here. See this? So this is the trabeculae. See that? Okay. So the little, like I guess layers inside the um, lymph node. So trabeculae of lymph node. See this? This is trabeculae. Okay. Okay. And then the functions of a lymph node are nonspecific filtration by macrophages, circulation of B and T cells, and immune response activation. So functions are nonspecific filtration by macrophages, circulation of the B and T cells, and immune response activation. So functions are nonspecific. So function of lymph node are nonspecific filtration by macrophages, circulation of B and T cells, and immune response activation. So what this means is filtration by functions are nonspecific filtration by macrophages. What that means is the macrophages in the lymph node sinuses phagocytose pathogens, debris, and antigens that are carried into the lymph node by afferent lymphatic vessels. So the macrophages in the lymph node sinuses phagocytose pathogens, debris, and antigens that are carried into the lymph node by afferent lymphatic vessels. So bacteria, antigens, bacteria and antigens come into the lymph node, by afferent lymphatic vessels, and then the macrophages that are inside the lymph node kill those antigens and bacteria that come in. So in the lymph node, you also have circulation of B and T cells. So circulation of B and T cells means that the B and T cells continuously circulate through the blood and lymph nodes to look out for antigens and then exit the lymph node to the efferent lymphatics if there is no bacteria. So the B and T cells are continuously circulating throughout the body. There are lots and lots of lymph nodes in the body, so the B and T cells go through lymph nodes, look for bacteria to fight, and if there is no bacteria, they just exit the lymph node through the efferent lymphatics and go on to the next lymph node to look for more debris, cancer, bacteria, pathogens. And then the next one, lymph nodes do immune response activation. What that means is um, there are dendritic cells inside the lymph node, and on the dendritic cells there is something known as MHC class 1 and 2. These MHC class 1 and 2, they're located on the dendritic cells. Where are the dendritic cells? In the lymph node. So The dendritic cells in the lymph node have MHC on the dendritic cells. These dendritic cells in the lymph node present antigen by MHC to CD4 and CD8 T cell. So this is something I actually struggled with, but finding out the location of everything really helps. So inside this lymph node, there is something known as dendritic cell. Dendritic cell is something that fights, it's a part of the body's immune system, it fights against bacteria. So dendritic cells have something known as MHC on top of it. And this MHC grabs the antigen and gives it to the CD4 or CD8 T cell that are circulating through the lymph nodes to kill it. So that's how it works. So dendritic cells in the lymph node have MHC on top of the dendritic cell. These dendritic cells in the lymph node present antigen or bacteria by MHC to CD4 or CD8 T cell. Okay, we'll get into that later, more in depth, but that is the kind of like a basic understanding. So lymph nodes are something, they're located outside the organ, and it takes all the debris from the organs. So that's where all the debris accumulate in the lymph nodes, right? It won't accumulate in your lungs or your GI tract. It will, the bacteria and the pathogens all accumulate in the millions and millions of lymph nodes around the organs. Okay. So next we have parts of the lymph node, which is follicle, medulla, and paracortex. So follicle, lymph node has three sites: follicle, medulla, paracortex. The follicle is a site of B cell localization and proliferation. Follicle is in outer cortex. Primary follicles are dense and quiescent. Secondary follicles have pale germinal centers and are active. So what this means is site follicle is here. This is a follicle. That's a follicle. That's where B cells that come into the lymph node go and set up camp there, and they multiply there too. So site of the follicle is a site of B cell localization and proliferation. That the follicle is in the outer cortex of the lymph node. Primary follicles are dense and quiescent. And the secondary follicles have pale central germinal centers and are active. So the primary follicles are this. So this is a primary follicle. Yeah, so primary follicles are dense and quiescent, means they're sleeping. So primary follicles are inactive B cells that become active once the antigen comes into the lymph node, and then B cells need T cell help. Then the primary follicles, which were sleeping, becomes secondary follicle with germinal center because they need to fight. So primary follicle is, it'll be dark, like this right here is probably primary follicle in this area. They're harder to see because they're like here. They're dense. They're a bunch of lymphocytes, B cells, that are not active. They're sleeping, and they will look dark on a lymph node. So they're probably like right here and like right here, right? That will be primary follicles. Next, we have the secondary follicle. Um, Secondary follicles have pale central germinal centers and are active. This is a secondary follicle. These are active B cells. They're ready to fight, right? Um, this is a secondary follicle, and they have a germinal center on the inside. Okay, so yeah, the pale center is the germinal center. That's how you should know that. Okay, next, medulla. The medulla consists of medullary cords, closely packed lymphocytes and plasma cells, and medullary sinuses. Medullary sinuses communicate with efferent lymphatics and contain reticular cells and macrophages. So medulla consists of medullary cords, which are packed with lymphocytes and plasma cells, and they also have medullary sinuses. Medullary sinuses communicate with the efferent lymphatics and contain reticular cells and macrophages. So here you see the medullary cords here, medullary cords. So this is the medulla, this part, see the medullary cords here? So this right here, this would be the medulla. Think of it as the middle. That area has a bunch of lymphocytes and plasma cells, and this um, and sinuses that connect with the efferent lymphatics. They connect with the efferent lymphatics, and macrophages go out through this way. So medullary sinuses have macrophages there. They connect with the efferent lymphatics and send the macrophages out of the lymph node too. Okay, there was a correction that needs to be made. Macrophages actually stay in the lymph node in the medullary cords to fight whatever comes into the lymph node. Efferent lymphatics carry the lymph fluid, and B and T cells out of the lymph node. This first aid is just written like that. There's bullet points, so you have to understand each and every point. So what they're saying is medullary sinuses communicate with the efferent lymphatics and contain reticular cells and macrophages. So what they're saying is medullary sinuses, communicate with the efferent lymphatics, and the medullary sinuses also contain the reticular cells and macrophages. So the macrophages stay in the lymph node, specifically in the medullary cords. In the efferent lymphatics carry lymph fluid and B and T cells out of the lymph node. Okay, that's the middle part of the lymph node. Okay. And next we have the paracortex. The paracortex contains the T cells. This is the regional cortex between the follicles and the medulla. It contains high endothelial venules through which B and T cells enter from the blood. It is not well developed in patients with DiGeorge syndrome. The paracortex enlarges in an extreme cellular immune response, like in Epstein-Barr virus and other viral infections. You will see paracortical hyperplasia and lymphadenopathy. So what they're saying here is um, paracortex is the area between follicles and the medulla. Between follicles and the medulla. So it's this area. That's the paracortex. Para means next to. Uh, so the cortex is uh, this. Yeah, the cortex would be next to the paracortex. So this is the cortex, and this is the paracortex. It's right between the cortex and the medulla. Cortex and the medulla. Okay, so that area contains high endothelial venules through which T and B cells enter from the blood. It is not developed properly in patients with DiGeorge syndrome. In patients with DiGeorge syndrome, there is thymic aplasia, so no T cells. So if no T cells in the body, then no T cells can be used to make can be used to make the paracortex. So in DiGeorge syndrome, they don't have a thymus. Remember, and that's where thymus is what? Thymus is where the T cells mature. So there's no T cells because there's no thymus in DiGeorge patient. Then no T cells uh, can be used. Then no T cells can be used to make the paracortex. So that's why the paracortex would be underdeveloped in somebody with DiGeorge syndrome. Paracortex enlarges in extreme cellular response, like in Epstein-Barr virus and other viral infections. You will see paracortical hyperplasia. Yeah, so you will see the paracortex undergo hyperplasia in somebody with Epstein-Barr virus, and you would see lymphadenopathy. So huge lymph nodes. That's why in Epstein-Barr virus you see huge lymph nodes. See? These are all lymph nodes. In Epstein-Barr virus, you know how I said we had millions of lymph nodes? We don't. That was an exaggeration. But we do. It's in the hundreds. It's not in the millions or the thousands. It is in the hundreds. Around 600 lymph nodes. So, but it looks like many, many tiny dots. So in our eyes, it looks like millions. But so this mononucleus, yeah. So you see these enlarged lymph nodes here. These lymph nodes are what we were just talking about. Those little purple picture that we just saw on first aid. That's a lymph node. This is a lymph node, and here actually the paracortex is being like it's swollen because in the viruses the paracortex undergoes hyperplasia. So in Epstein-Barr virus, you will see huge lymph nodes because the paracortex is undergoing hyperplasia. Making a note. So what you need to know, what you need to know is that cortex, the cortex of the lymph node has B cells, and the B cells make antibodies. The paracortex has T cells, and the paracortex is where there is high endothelial venules. Medulla has macrophages, and the medulla is on the inside of the lymph node towards the middle. Okay. Lymph node clusters. Okay, so lymphatic drainage associations. Okay, this page, y'all, is so super high yield that I would say it's probably the top 10 most important, one of the top 10 most important pages of first aid. You have to really really know this. Okay, all right, we're gonna go lymph node cluster. Okay, um, so this is the name of the lymph node, um, wherever in the body uh, that lymph node is located, and the area of body drained is whatever area that lymph node drains. The associated pathology is related to cancers from that lymph node. Okay, so remember how we talked about B and T cells circulate throughout the lymph nodes, macrophages stay in the lymph node, um, but then B and T cells, dendritic, and the macrophages all fight cancer. They all fight any type of pathogen that comes into the body. These pathogens go straight to the lymph nodes instead of going to the tissues. Lymph nodes are there to protect us. So um, that's why you have swelling of the lymph nodes when you have a virus, or like for example, in a cancer, the lymph node in that area, it's swollen, right? So we're gonna get into that. Lymph node cluster. We have cervical and we have supraclavicular. Okay, we have cervical and supraclavicular lymph node, cervical and supraclavicular. So cervical lymph node is right there below your neck. Supraclavicular is right above your clavicle. Um, these two lymph nodes drain the head and neck. So the lymphatic vessels coming back from the head and the neck drain into cervical and supraclavicular lymph nodes. Here the associated pathology is upper respiratory tract infection, infectious mononucleosis, and Kawasaki disease. Okay, so in Kawasaki disease, I want to look this up. So you see this right here, Kawasaki disease is swollen lymph nodes, right, um, it'll be in the neck, right here in the neck. So the cervical lymph node, it was cervical. So this is supraclavicular, this is right above your clavicle, and the cervical lymph node should be here. So yeah, this is a cervical lymph node, and that's the cervical lymph node is what drains um, neck when somebody has Kawasaki, when a kid has Kawasaki disease. That's why their neck is swollen. Okay. And the cervical and the supraclavicular region also swell when uh, you have infectious mononucleosis. Here's here's a good picture. So you see right here, swollen. Your neck is swollen. Now remember, cervical and supraclavicular lymph node will swell when you have upper respiratory tract infection, infectious mononucleosis, or Kawasaki disease. Next, we have mediastinal. Okay, so here we have mediastinal, which is right in your medial chest. Mediastinum. Um, mediastinal lymph node will drain the trachea and esophagus. So if there's any issues in your trachea or esophagus, it will drain to the mediastinal lymph node. The associated pathology here is pulmonary tuberculosis and sarcoidosis and primary lung cancer and granulomatosis disease. Pulmonary TB. Okay. So if you have tuberculosis, it's going to go to your mediastinal lymph node because tuberculosis, the way you get it in your lungs, you breathe it in through your nose, and your trachea, and it goes into your lungs. Okay, so to protect the lungs, to protect the lungs, the body will shift the tuberculosis bacteria to the mediastinal lymph node. So I'm going to think about it. So sarcoidosis, same thing. Sarcoidosis, it's an issue of the lungs. So to protect the lungs, or maximum to protect lungs as much as the body can, it will shift the sarcoidosis not even bacteria, but sarcoidosis issue to the uh, mediastinal lymph node. Primary lung cancer, which is lung cancer starts in the lungs. The body will try to help the lungs not get cancer because the way that the body identifies the cancer is that it's like a antigen, right? Like a foreigner. So it doesn't. I don't think the body knows that it is actually cancer. So whatever it is, just a foreign thing. So the mediastinal lymph node, it will shift. The body will shift the foreigner to the mediastinal lymph node, and that's why in primary lung cancer, the mediastinum will swell. Mediastinal lymph node will swell, and also in granulomatous disease, the mediastinum will swell. Okay, so we have two things: so mediastinal, and hilar.